And make sure to get my captions on. All right. So if anybody needs captions, they should hopefully be operational. Okay, so welcome. This is our first of our engineering panels. We're talking about careers in STEM. I'm so grateful that you all were able to join us. So thank you very much. We'll start with going through and doing some introductions. So if you can tell us your name, job title, what degrees you currently hold or are working on, and then just a brief description of your specialization or the area that you work in for our guests. Hannah, let's start with you, if you don't mind.
Yeah, sure. So my name's Hannah. My job title is I'm a failure analysis engineer. Degree was electrical engineering, just a bachelor's. I didn't do anything more than that. And I guess the brief description is the semiconductor failure analysis. So semiconductors are like the chips that everyone was hearing about when it was like the chip shortage. So that's what it is. And then the failure analysis is just when it's not working properly, I figure out why is the, I guess, brief description of it.
Awesome. Thank you so much. So can you tell us briefly, I know this is a big ask, what semiconductors are or what they're used for?
So they're used for like almost anything electronic, or if you just think of like tech, anything of that nature. So, phones, laptops, even, like washing machines, dishwashers, ATMs, like literally everything, anything techie has a semiconductor.
All right, awesome. Thank you so much. I appreciate it. Jim, did you want to chime in next?
Okay, hi. My name is Jim Ledesma. I am a business development focal for the Boeing Research and Technology Group, and I specialize in structures, materials, and manufacturing. I got my BS in mechanical engineering from UC San Diego. While I was at school, I interned at North Island, and then I got my master's in mechanical engineering from University of Utah with a Navy scholarship. So I worked at the Navy at North Island doing failure analysis, but I was doing failure analysis of aircraft structure, and got to fly out to an aircraft carrier once for an A6 mishap. So that was probably the highlight when I was working for the Navy. And then after I got my master's, I got a job working for Boeing. So while at Boeing, I've worked commercial aircraft. And then actually, because of that, I worked a TSA bomb blast program, so kind of anti-terrorism. So we got to blow up an L-1011 legally to see kind of what the size bomb the detectors had to find. Also worked military C-17 doing fatigue and fracture, and then worked space side working X-37, which is like the unmanned space shuttle, mini space shuttle. And then, like I said, currently doing strategy and development of CRAD, which is contract research and development with the US government.
Quite the career, Jim. Wow, that's amazing.
Yeah, working R&D, it's nice because, in the old days, there's guys that I knew that worked their whole career on a C-17 flaperon fitting, specialist. And with the R&D, you usually got a new project every 2 or 3 years. So
Neat. Awesome. Roey, did you want to follow Jim on that?
Yeah, so my name is Roey. I'm an embedded software engineer, and I have 3 years of experience. I primarily specialize in bare metal embedded, and most of that involves IoT and sensor technology with regard to my past jobs. I've gotten a degree in electrical engineering from UC Santa Cruz, and I only have a bachelor's degree.
IoT. Can you elucidate that for me?
Yeah,
Thank you.
so IoT is it's Internet of Things. It's just an umbrella term referring to any sort of wireless communication between small devices, which are the devices that I tend to work on, the embedded devices that you'll see on watches, fridges, anything that isn't a full-fledged, workstation or PC, and the wireless communications that are associated with that. So sending the information that's collected via Bluetooth, Wi-Fi, and there's other protocols like Zigbee and things like that.
Awesome. Thank you so much, Roey. Corey, sorry to make you go last, but if you can follow up on that.
Yeah, I think I was in here last, so it works out perfect. My name is Corey. I work with a firm called Siska Hennessy Group, and we're in the construction industry. Typically, it's called AEC, Architecture, Engineering, and Construction. I work on the design side, so the easiest way to say it is like blueprints. We make blueprints, although blueprints don't exist anymore. Everything is just PDFs, and you can zoom in and out of them. You don't see them in paper anymore. And I specialize in plumbing engineering specifically. So basically like fluid dynamics, or if you wanted to be more funny about it, poop pipe. Uh, some of our main stuff that we do if it's just a simple kind of commercial office build out. But then, obviously if we're working on an airport or lab or anything like that, we get to do other really cool things with fluid dynamics.
That's awesome. And then what degree did you get? And from what?
Yeah, totally missed that one.
No worries.
I got an environmental engineering degree from San Diego State, and I've been in the field for about 3 years. So I graduated in the middle of COVID. That'll be, I think, my number 3 and number 4, how that happened.
Wow. Yeah, that I think Roey would maybe you were in a similar situation. So exciting time to graduate. Awesome. Well, thank you all so much for being here and sharing your time. We really, really appreciate it. So I think one of the questions that our students frequently have, I know I have. I was mentioning to the panelists that when they were coming in that I am not an engineer. I'm a chemist, and I know very little about all of your fields. So I'm as interested in learning as I'm sure our students are. But what do you do in a typical day at work? It looks like I'm going to start with you, Corey, but it looks like you're in the office. So I'm guessing that your day involves being in an office. So if you can just kind of go through and describe your typical day, that'd be great.
So in this industry on the design side for mechanical, electrical, and plumbing engineers, we are typically not working on just one thing. We're working on usually like 10 to 15 different projects. And so based on that, you have a lot of emails. So typical day is I sit down and the first 2 hours of my day is all the people that stayed up until 12 o'clock at night doing whatever they were doing and sending out their emails while I was sleeping. I get to look at those, answer those, and sort of every morning I get to like rebuild my day and, you know, put the hours that I need to put for the submissions and priority levels of all the different projects that I'm working on for that specific time. And just without going like it's so easy for me to go super down the rabbit hole because I'm a nerdy engineer. So I just keep it at that. Basically, I set up it, I come in, get coffee, look at my emails, and set up my priorities for what I'm going to be doing, whether it be, designing that day or whether it's more, business development type project closeout, or whether it's answering questions that contractors, have about our design. So that's basically how it works, right? The contractors are like, "Oh, you didn't do this good. How do you do what does this mean on your drawing?" So then we have to like explain it to them. Um, and then sitting in, coordination calls, those are super fun. Um, I don't find a lot of coordination happens in them, but we're supposed to be there. So, and that's pretty much a typical day.
All right. So there's as probably as much design work as there is communication
Yeah.
between the project, the project developers, who are you guys, and the people who are asking for the project to be done.
Yep, I would say that it's maybe even more.
Yeah.
In the beginning, it takes you a little bit to, but once you know the form, there's like your Big Ten formulas you're using every day, right? So you
Mhm.
get so used to them. And in the professional world, as opposed to school world, there's just a big book with all the answers in it. And then what
Mhm.
they're like, oh, this is the equation that's used, and here's the next 750 pages of answers. So then you just like, okay, what was my input? Okay,
Mhm.
cool. Oh, there's the answer, and then you just pull it out. So you have to
Mhm.
understand how and why you got there, but then, so you get really good at doing the design thing, and it becomes really important is communicating how to best communicate what you're trying to say, like
Mhm.
on paper with lines and drawings and things like that. So it's super important communication, like top,
Wonderful.
top, top. I mean, it's not even close, I don't think.
Yeah. Awesome. Thank you so much, Corey. Hannah, did you want to add to that?
Sure. So my typical day kind of starts similar, where I kind of come in, check email, kind of plan out the day, usually get my coffee, start kind of slow, all that. But then after that, I guess the way that our work is kind of structured is, so with failure analysis, just the way that my group is set up is when, failures will come into our group, it'll get assigned to one of us analysts, and there's like 5 or 6 of us, and then we'll kind of be responsible for doing the whole um, analysis on that. We can kind of help with those. And so they can range in like how long those will take. It could be a couple days to like, a month or something like that. And also kind of ranges how many of those I'll have at a time. Usually it'll be in like the 1 to 3 range though. And so kind of starting off the day, it's usually just to make sure like, okay, there's no kind of little emails I need to respond to. And then I'll start kind of planning out, okay, with the jobs I have now, which ones are more higher priority? How do I, which ones am I going to work on more today? And then from there, I'll usually go into the lab. And so it's a pretty hands-on actually. Like I have a desk and you have to come into the office because it's all lab work basically. So I do really like that about it, is that it's very hands-on kind of work, but also not like manual labor at the same time. It's in like a nice temperature controlled environment. Um, so that's always nice. Um, but yeah, so then it's just kind of the day will vary kind of depending on what techniques or where I'm at and the analyses for the different ones. But the vast majority of my time is kind of spent in a lab, and then kind of run back to the desk to check email and write reports if I have to when I'm done with a particular analyses.
Wonderful. Do you ever work collaboratively with other analysts on a particular project?
Um, yes, but then it still kind of is whoever is, assigned a particular analysis. It is like at the end of the day, their responsibility for making sure everything is, going well with that and kind of
Yeah.
provide a report at the end and all that.
Right.
But we all kind of do have our own subspecialties. They're kind of just things that we've taken an interest in a little bit more.
Mhm.
So kind of while we're working on things, sometimes people will come to me with like, okay, hey, can I run this by you? Kind of just like we'll work collaboratively in that type of a way.
Okay.
Just running ideas by each other and things like that. Or if somebody has more expertise in a particular area,
Wonderful. Awesome. Thank you so much, Hannah. Roey, do you want to share with us your day?
Yeah. So I know this is probably going to sound cliche, but every day is different. At least from my experience so far, there are some days that are going to be a lot more logistics, planning, which people work on what, how teams are going to be organized. And then I'll have days where I wake up and I just get to it and I start working. But to give sort of a more overall perspective on things, there is a lot of integration with other teams that tends to come into play. Embedded by nature is a multi-field line of work. So you're going to be working with the hardware team to either figure out what the hardware problems are. If you're working with the electrical engineers, seeing, okay, maybe this isn't a software bug, maybe the PCB has some sort of issue. You could be working on with the mobile app developer team. If you have an associated app and you're working on some consumer device or something like that, then you would be working with them to figure out different packet structures, figure out what data should be sent over and why and how, that sort of thing. But as far as the core work, I'd say it's split up into one of two things. Either I'm going to be debugging a current feature or implementing a new one. And that is just digging through code when it comes down to it. I'm going to be looking through code, trying to figure out where to put things, trying to figure out how to structure a new feature, or looking through code, frantically trying to find where the problem is.
Awesome. Thank you so much. So a lot of time sitting in a computer. That was one thing I forgot to ask you. Well, Heather, you mentioned that sorry, geez. Hannah, you mentioned that you work in the lab mostly. So you're mostly in the office. Roey, it looks like you are maybe a little bit more flexible in where you're able to work.
I am also in the office.
Yes.
This is I got very lucky. This is generally rare. Usually you would see me without my room background and probably more dressed up. But yeah, remote work applies heavily to a lot of software engineering disciplines. To embedded, not as much, depending on the industry. My prior job was working with smart lighting for first responder vehicles, and that couldn't be taken back home. I was working with a lot of big lights, a lot of high power things that required the use of different lab tools and expensive equipment. But depending on the specific niche that you're in, if you're working on something small they could take back, remote can definitely be an option. And this is far from the only remote embedded job that I've seen listed.
Gotcha. I think that was more my curiosity, is if there are remote positions and if they are common. Does that make sense?
Yeah.
So I think you spoke to that. Corey and Hannah, did you want to speak to other areas of your field? Sorry, I'll go with Hannah first. Sorry.
Yeah, sure. So for like failure analysis, like semiconductor failure analysis specifically, that is very lab-based. So there's not really much remote work you can do. I know some companies sometimes will have it where their engineers will like tell their technicians what to do. And then in that case, you could be a little bit more options for remote. But I think still for the most part, the failure analysis specifically, it's usually in person. There's other jobs within the semiconductor industry that certainly can be remote though.
Sure. Okay, great. Corey?
Yeah, so the AEC industry, kind of construction industry, on any particular project, we have 10 different firms that have their own amount of whoever many people that are working on them. So, like an architect, for instance, the MEP firm, which was us, and in us, for what that stands for, MEP, it's mechanical, electrical, and plumbing. All that needs to be coordinated. So for instance, I have a water heater that I need electricity for. So I have to tell the electrical engineer, I need, 120 volt, whatever, 460, three phase, blah, 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 blah. Sometimes I have to work with the mechanical engineers because we're going to, realize a little bit of sustainability, and we're going to steal some of their hot water out of their pipes to preheat our water so we don't have to waste as much, resistive heating electricity in our water heaters, for instance. Civil engineers, we work with them all the time. Structural engineers. So there's just like a lot of different people that are involved in putting in a building. And so again, back to that coordination, that communication piece is really big in our industry.
So do people typically work in office then?
Yeah, so we, as an MEP firm, I think that during I was hired during COVID, and they were already like we've been in the office. We I think we left the office for like a month, and that was it. We were in the office and we haven't left. We do have a remote Friday, but it's just kind of like one of those, the perks.
Got it. Okay,
Keep people
great.
happy.
All right, thank you. Jim, thank you for.
Oh, sure. So I'm actually remote, mostly since COVID. And it's mostly because I'm supporting teams in, here in SoCal, Seattle, St. Louis, Huntsville, and Charleston. So I can have meetings at 5 a.m. Pacific, which is for 8 a.m. Charleston. And then also sometimes we'll have some of our international centers. So we'll have a meeting like at 10 p.m. So it's really nice to be able to just tie in real quickly from home at 5 a.m. or 10 p.m. Most of the stuff I do at the day is, emails, WebExes with the different sites. We are traveling more now. So I go to conferences, to government facilities, and then to the Boeing sites. By the end of the year, I still have to go to Charleston, Seattle, and Nashville. And mostly I'm reviewing, like we have 70 contract kind of proposals we're shaping. So kind of getting statuses from the subject matter experts, and then kind of briefing my leadership of where we are for CRAD, because we do have a year-end goal we're trying to hit. That's mostly my day.
Okay, so it sounds like maybe the position that you're in is more of a, I don't want to put words in your mouth, but more of a senior position, something that you kind of have evolved to in your career. Would you say that that's accurate?
Yeah, so because I used to be, a mechanical engineer doing structures. Then we had a business development focal who was a business guy, but my VP said, I want a technical person to be able to talk to the customers. So that's when they asked me when that person retired, I went in. So yeah, the only time I really go into the office is if I have to go into a skiff area, or we're actually having face-to-face meetings with folks in SoCal.
Okay, great. Wonderful. Thank you all so much. Okay, so the next question I think is kind of at the heart of why people go into engineering. And I'm going to start with you, Jim, since I left you to last here. So what drew you to engineering? Did you start off knowing that you wanted to go into engineering and then choose a specialization? Or did you start off pursuing another avenue and pivot to engineering as a specialization related to your original academic path?
I always was going to be an engineer because my dad always said, like, you're going to be an engineer. It's from such a young age. I didn't even think about other stuff. I remember when some high school friends were like, oh yeah, I'm not going to go to college. I was like, is that even an option? I did, didn't even think that, that was an option, because it was just so kind of from a young age instilled. But I did switch. I really liked chemistry when I was in high school. And then when I was at UCSD and I took a chemistry class, I'm like, oh yeah, I don't like chemistry anymore. But I still like the mechanics and physics. So I shifted to mechanical engineering. And when I was going to school, that's kind of when Top Gun was really big. So everybody wanted to be a Navy pilot. But I had bad eyes, so I couldn't. So then I shifted and was gonna do a nuclear engineering scholarship with the Navy for the last 2 years. And then I had already done the physical, started some of the paperwork, and then they increased the requirement and added an extra 2 years of commitment. And then I kind of backed out of that. But then I got that internship with North Island and did that. But I don't know, my path went, from really engineering, worker bee, doing failure analysis, fatigue fracture. And then once I got that experience and knew what to look for and knew where there was maybe some problems, so they moved me into systems engineering to I had a little bit broader base. Then they moved me into project management. So then I got to learn the business side, tracking actuals, schedules. And then from there, because my network had really grown internally and externally with government customers that I was working these projects for, that's what then allowed me to pivot to business development.
Quick question as a side note. Did you have a family member that was an engineer?
No.
No,
My
but
dad
your
just,
parents just decided that's what you were gonna do?
yeah, both my parents were in education, and my dad was like, don't be a teacher. But my brother's a teacher, but but yeah, he just said, you're gonna be an engineer. I'm like, okay.
Is this a preview for me with having conversations with my children?
Yeah.
Don't go into teaching.
Well, yeah, well, it was funny because um, I got into UCLA, UC San Diego, and San Diego State, and all my friends were going to San Diego State. So I told my dad, I'm gonna go to San Diego State. He's like, well, you can go there if you pay for it, or you can go to UC San Diego and I'll pay for it. So I'm like, oh, okay, yeah, I'll go to UC San Diego.
All right, there it is. There it is. Interesting. That's really interesting. Roey, did you want to follow up on that?
Yeah. So I actually initially never intended on being an engineer in any capacity. I wanted to be a doctor. That was the three options I had. I could be a doctor, lawyer, engineer. So I picked option one. I lasted about a year in bio, and it is really heavy on memorization. I think the field is fantastic for people who are into really understanding it if they're really interested in that field. But the memorization aspect was a bit too much for me. So I started shopping around for different options. I heard from a friend that electrical engineering is something that nerds tend to like a lot and it pays a lot. And I was like, hey, I'm a nerd and I like money, so I switched to that. But thankfully, I still do like electrical engineering. It's what I graduated in. I still find it fun. I find it fascinating. But what I am thankful for is that through my electrical engineering curriculum, I was able to discover embedded as a broader field, and that was my actual passion. And so EE did great for me for helping me discover that and helping segue into that.
Was there a particular class or opportunity that introduced you to embedded?
It was well, I've known about embedded
Mhm.
in a general sense a little while before then, but the first class I took was an embedded specific class. They
Okay.
touch upon everything a bit, and I took that class. It was really hard. I could not get anything figured out until about halfway through the semester, and then once everything finally clicked, it was not smooth sailing, but it was definitely a lot easier, and the grades started getting better. But I was hooked, and I liked it so much that I took the follow-up course, which was a much more serious and much more in-depth course. Then I took a course that was related to sensors and sensing technology, which also had an embedded sort of tie-in.
Mhm.
And I'm sure that depends to a great extent on the university and the courses that it offers, but maybe I got lucky. They had some specific embedded classes available to undergraduates, and those happen to be the ones that I took.
Is embedded a field that you could get a degree in, or is it a kind of a subsidiary of other areas?
I'm sure there's some sort of embedded degree or embedded specialization out there, but for the most part in the industry, I've seen that embedded engineers tend to be either electrical engineers, hardware engineers that have independently learned CS or at least elements of CS and found that middle ground in embedded, or they're CS majors, they're programmers, they're software engineers who either learned the hardware component via traditional ways. Maybe they got a master's, or they learned just enough that they could then shift over into embedded.
And CS is computer science.
Yeah, computer science, computer engineering. Computer engineering tends to be a little bit more well suited for embedded engineering as a field in the industry because that touches upon some more low layer concepts. So you'll see a lot more of the hardware aspect with computer engineering.
Okay, wonderful. Thank you so much, Roey. Okay, so I think Heather. Oh my God, that's so embarrassing. I decided that your name was Heather before you even came on, and it's not in your name tag. So I'm sorry. This is what, the 17th time that I've done this? Hannah. Okay.
Yeah. So I was actually kind of similar. I also started off where I wanted to go to med school and become a doctor. And um, I remember it was at the orientation. So I went to UC Davis, and they have a bunch of, pre-med stuff. And I remember in the orientation that I was in for, it was like the College of Biological Sciences, the dean went up there and did the thing of like, all right, everybody raise your hand if you think you're going to go to med school. And it was like, the whole auditorium. And she was like, okay, I'm just going to tell you, like, most of you aren't. And like, it's not a bad thing. It's just, I'm going to guess most of you all think you're all going to go to med school because that's something you can picture yourself doing. It's because that's a career that you've seen and you find that interesting. So like, just want to encourage you all to be thinking your whole time that you're here about, what other things are there that I just don't know about that actually might be, more well suited towards, me and my lifestyle and just, strengths and things like that. So, I mean, I was already kind of thinking that already because it's like, being an 18-year-old, being like, yeah, I'm going to be in school for like 12 years, paying on $300K of debt, all that. So kind of just the practical side of me was like, that seems cool, but like, let's maybe not be all in yet. So I kind of just, was thinking, kind of looking through the list of majors and stuff like that. And I saw biomedical engineering. And I thought like, oh, that's kind of interesting. So it's like, okay, like, that's still kind of in the medical field. It seems kind of cool, but maybe a little more math heavy, physics heavy, because I guess at this point I knew for sure I wanted to do STEM. But within that, that was still pretty open. So I switched my major to biomedical engineering, did that for like a year and a half or so. And then it was just kind of when I was looking for internships and things like that, I was just like, okay, what are the actual careers that you would have if you were a biomedical engineer? And I was just noticing that there weren't all that many, like there were options out there, but a lot of the different just, job postings I was seeing would be like, chemical, mechanical, civil, kind of the more basic engineering things. And so at that point, I kind of just thought about it again and was like, okay, like, I guess, why do I really want the biomedical part of the engineering? So I was noticing that just with my classes and stuff, I liked more of the engineering type classes versus the bio. So I was like, why am I keeping the bio in this one? I'll just drop that and do some other type of engineering. So I thought about it for like a couple days and was like, well, I don't really know what the jobs will be like, but let's just pick some type of like very general engineering. So I was like, okay, it's like civil, mechanical, electrical. Those are like the most general ones I can think of. And I kind of was like, well, like in all my physics classes, I always kind of liked the like electromagnetism stuff more than the mechanics. So like electrical, here we come. And that was pretty much like, I think I thought about it for like a day or two. And it's like, sounds good. So switched into that, kind of having no idea what the actual jobs would be like or anything of that nature, but was still just like full speed ahead. And it worked out. I'm very glad. But yeah, just went through. And then I think to actually get into my particular field, it was kind of a little bit more of the same. I was just looking for like internships and jobs. And I found an internship that was during the school year at like a local company. And so I was like, perfect. I want to work at Dining Commons. You can get income during the year, but like, and I did not care what it was. It was just like electrical engineering, sign me up. And it was in the semiconductor industry, kind of adjacent to failure analysis, very similar. And so it was kind of that experience that got me kind of helped me tailor down like, okay, what do some of the jobs actually look like? What am I good at? What do I like? A lot of it was talking to some of the, just the people who worked there too, who had, 40 years experience. You can just be like, ask them all kinds of questions and stuff. We worked there. So having an internship was very helpful, partially because I realized, okay, I do like this field, and there's probably plenty of other kind of smaller fields within electrical engineering or even other types of engineering I would like. There's probably plenty of things I could do, but it was like, well, I like this one, so may as well let's go with it.
Awesome. Yeah, I think it's really good for students to hear that kind of evolution of where you start and then where you end up, because I think when we first start going to school, we think, oh, people just know where they're going to go, right? Because it looks like that when you look at other people who have already gotten somewhere, right? You don't see the journey, you just see the destination. But yeah, no, I think that's fascinating. It's great to keep an open mind, right? To be okay with, well, this may be where I started, but maybe that's not where I'll end up, and just being okay with that part of it. So awesome, thank you. All right, Corey, do you want to share with us?
Yes. No idea I was going to be an engineer. The first time out of high school, I had a full ride scholarship as a music major, classical guitarist. I failed out of school after about a year. Ended up in the military for 8 years. And then when I got out, I was obviously a little bit older. And then it was kind of really crunching the numbers and being like, I think I'm going to be able to make the most amount of money doing engineering. And I always did think, first off, I don't know if you guys know this, but music is really mathematical. It's very mathy. I firmly believe that there's a lot of creativity in solving math problems. I know that a lot of people don't agree with that. They're like, oh, you just put the formula in and then it's done. And it's like, I don't agree with that at all, because taking whatever it was before and turning it into the thing that you can put the formula into and then get out the answer is like every single person sees it completely differently. I mean, just look at a math test. Everyone got there a different way. So I really like that part about it. So I was like, oh, okay, cool. And then as far as environmental engineering, talked to a couple of people. I think I went to one of these classes when I was at Mesa, or one of these panels when I was at Mesa. And somebody told me that environmental engineering was the easiest of the engineerings. So I did that one. Turns out I don't actually agree super a lot with that. Typically chemistry is a subject that a lot of people find really difficult, and there's a lot of chemistry in environmental engineering. It's basically water chemistry. Water resources engineering and chemistry is what an environmental engineering degree is in this region, because we're in the middle of the desert and there's no water. So
I think one of my friends, my buddies that I went to Mesa with might have taken that same thing, that
yeah.
same course. He was like, I want to be an engineer, but engineering was the easiest of the SDS UCSD schools to get into. So
Yeah.
he was like, oh, I'll go environmental. So yeah, sometimes you pivot for unexpected reasons, and then you find yourself in a place and you explore that place, and if you like it, then you stay, and if you don't, then you find another place. But yeah, wonderful. I totally agree, by the way. I think that music and science, STEM, really go hand in hand for that. And I think there's a lot of people in STEM that are also musicians. So yeah, wonderful. Well, thank you all so much. Those are all really elucidating. I think that we kind of covered the fourth question, which is how did you learn about your current field and what resources helped you get from degree to career? So I'm going to go ahead and skip over that question. So I'll start with, what are some of your favorite things about working in your field? And we'll try and keep it brief because we have several more questions and a short amount of time. So Corey, did you want to start us off with that? What do you like about your field?
I'll try to not keep it political. I really like doing the math and engineering part and the design part. I really don't like the corporate stuff of the business. I very much don't like that. It's a necessary evil, and I guess I'm sort of good at it because they have me doing stuff in that realm all the time. But yeah, so my favorite thing about the field is doing the actual design work and thinking about creative, sustainable solutions in the built environment to produce, a cool, fun project.
That's awesome. Yeah. So it sounds like, again, you're really leaning towards the creative side of things.
Mhm.
So it's great. Let's see. Hannah, did you want to chime in on that?
Yeah, so I really like that it's I like the hands-on nature of it. I like that I don't spend all that much time at my desk. It's a nice balance between the two. I also really like that the industry is kind of always changing a little bit. So if you think of like, just tech things from like the 2000s, so they've been rapidly improving and increasing and getting smaller and more complex and that kind of thing. So that's the whole industry is always changing. And so I'll kind of feel like once I get good at, one thing, then we'll get a new product that's even more complicated. Then you have to figure out how to do failure analysis on that. So it's that's nice too.
Awesome. Wonderful. Jim?
I like that in the R&D field, like I've worked underwater vehicles, I've worked aircraft, I've worked spacecraft. So I like that I have exposure to a really large field of innovative, game-changing technology. I also, like, interacting with people. I'm a extrovert. So, like my dad, you can drop me in the desert and I'm gonna have friends, in a matter of hours. And that really helped get me into business development business. It's all about networking. But those are my favorite things.
Wonderful. And I'm so glad you brought that up too, because I think one of the things as you're going through college that you kind of explore is what level of interaction do I want in a workplace, right? And I for me, I love computers. I think they're fascinating, and that was what most of my undergraduate work was focused on. But I did not want to sit in front of a computer all day, which I appreciate that there are people who do, but I'm just not one of them. So yeah, kind of finding yourself and figuring out what you can excel at based on your personality and what type of day you enjoy having. Awesome. Thank you, Jim. Roey?
Yeah, so from sort of an overarching perspective of the field, I love the possibilities and applications of my skill set. Whenever I learn something new, or if I'm working with a new sensor, the first thing I think is, oh, this unlocks a ton of potential. This unlocks a ton of things I can do. Like when I first learned about Bluetooth, when I finally got a very basic Bluetooth communication going with the device in my phone, I was like, wait, now I can make anything talk with my phone. That's incredible. What's it going to tell my phone? Who knows? Whatever I want. But the thing that I really live for with respect to why I pursue this career is the little victories. It's when there's a bug that is so frustrating that nobody can find. It's been 2 weeks of me digging around, of me trying every possibility, every debug tool at my disposal, and then all of a sudden it clicks. That's my favorite thing. I wouldn't want that every day. I prefer a very mild challenge, just enough that I can get myself in a sort of flow state and get going and have consistent productivity. But when there's a really hard bug, solving it's a great feeling, and that makes the frustration worth it.
I love that. I get that payoff when I look at somebody's face, then the lights come on as a teacher. But yeah, I imagine that when you put that much time into a project, that's incredibly satisfying. So Rowie, I'll start with you in the next question. Do you feel accepted in your profession, and do you still experience imposter syndrome sometimes?
Yeah, so on a personal level, I think that I'm generally accepted. I think that there's a baseline level of respect for embedded engineers for the most part in the tech space. A lot of hardware engineers don't like touching software. They're definitely capable of it, and vice versa. They just don't like it, and a lot of software guys don't really like doing hardware. So the people that are able to be the glue in contexts where we're working with small embedded devices, I think that anybody pursuing that, regardless of how good they are, unless they're completely mediocre, but anyone pursuing that is going to have some level of respect. But it's been a welcoming field. People are empathetic towards, especially the younger guys. I'm pretty new to this industry. I've only been around for 3 years, and I've exclusively been in IC, so I haven't taken any sort of management roles. But from my personal experience, people are very, understanding of the fact that embedded is massively complex. A lot of the time it involves archaic tools. So any productivity that I'm able to churn out is something that, that's able to benefit everybody. As far as imposter syndrome, also, so I don't know if you guys can hear that. I'm just going to shut my door real quick. Sorry. Imposter syndrome, yeah, all the time. Often and a lot. I don't know if this is the case for people who've been in the industry for longer, but I sure get a lot of imposter syndrome. My friends who have graduated in my field still do, and I think a lot of it just comes down to the complexity of these things. There's so much. There's a wide breadth of different applications and different things that are only applicable to certain fields that there's no way of knowing it all. I mean, even on a language level, if you take something like C++, there's no way of knowing it all. So it's a big ask, and there's always going to be somebody who knows more about one thing and more about another thing. But hopefully that diminishes over time.
Awesome. Thank you so much. Jim, do you want to speak to that?
Yeah, I feel like I'm accepted. I get seeked out by Boeing leadership and by government customers calling me up to find out who they can go talk to. So I can, years of networking, I can connect dots pretty quick, or get to the right person in maybe one or two jumps. So that's really important. Imposter syndrome, I've been around long enough where I don't have it anymore. When I first started, yeah, I did, but now I don't. I'm pretty fortunate because a lot of people want my job and they ask, how did I get here? Because I control my own budget, I control my travel. I go talk to customers when I have to. I have quite a bit of latitude in my job.
That's great news, Jim. We all needed to hear that. It diminishes. Thank you. Corey, did you want to chime in?
Yeah, specifically for my case, at Cisco Hennessy, we do a pretty good job with a couple different types of like inner organization DEI programs. So I think that it helps pretty much everyone to kind of feel accepted. Again, we communicate a lot in the office. We can't not without, or we won't get our jobs done. So definitely feel accepted in the profession. And same with Roy. I experience imposter syndrome very frequently. Um, I I think it just comes from perfectionist kind of stuff. So that's just more of me needing to be better and more mindful about my emotions, where they're at, don't react. And but yeah, it's constantly like, oh, is it good enough? Is it good enough? And it always is. So I don't think that it's just one of those ones. It's like an internal thing.
Yeah, no, it always is. I think that's a good reminder that we should all tell. It's gonna be fine. It's gonna be good. Yeah, I like that. Thank you, Corey. Hannah?
Okay. So I do feel accepted at my current position, in my current job. But at my old one that I had, I definitely was not. So like I think as most people know, like there are not that many women in engineering. And so at the old job, I was definitely one of the few. And yeah, I was not really accepted very much. And so that was kind of why I quit that job and moved to a different one though. And so at this job currently I am. So I guess that kind of just goes to show that it's like, yes, that type of stuff is still out there in the industry, but there are, places and jobs and things like that where it's not the case as much. So you just have to look for those. Sorry. And then I did experience a lot of imposter syndrome initially, particularly more when I was in school and less when I was working, kind of like in the very first like year or so, but I don't anymore. So kind of probably the same thing. I think it gets less with more time. And I actually remember one very specific instance when I was, I think I was like in my last year, and I was standing at like in mine at a career fair or something, I remember hearing some people who were in my major, but I think they were like second year or something. And they were all talking about something like super confidently, all about it. And I don't remember what it was, but I just remember listening and being like, that's not accurate. And, it's like a whole group of them. And that was kind of a light bulb moment of like, okay, there's all these people walking around acting super confident, talking about all this stuff. And like half of them, like, they have no clue what they're talking about. They're just pretending like they do to like, for whatever reason. And that was kind of helpful of like, okay, even if it seems like all these people, everybody knows what they're doing, like, no, they don't. Like, we're all in the same boat. We're all in school. We're all confused. Like,
Also a good lesson to remember. Yeah, we're all always confused. I agree with that statement. No, I think it's easier to see on a teaching side, because I see that so viscerally every day that, everybody's at a different level and we all think that everybody else knows more until we realize that they don't necessarily. But I think it's still totally valid. I still feel imposter syndrome on a regular basis, especially when I'm in a room with people who are have been doing it for much longer, or especially when a student that calls me professor, it's still like I'm like, oh yeah, I guess that is me. So yeah, so I think it sticks with us, but it's good to know that it can lessen over time. Okay, so we got to the last question, and I think this is the one that our students really value the most, which is any advice that you have for students starting their degree in engineering, any recommendations or cautions or tools that you found really helpful. Do you want to start us off, Hannah?
Sure. Yeah, I think in general, just like if you are, we're probably in a lot of STEM things, of like you'll run into some like teachers who seem to be like they want to like weed out the weak or that type of thing. So like kind of once again, I'm just like everybody's confused. There are people who've been doing it for 40 years. Of course, it's easy for them, So like don't let like the overconfidence of others and things like that kind of deter you. Of like if you put your mind to it and you want to do it, you'll be fine. You should feel super confused, but like literally everybody does. So I think that's kind of would probably be my main piece of advice.
Yeah, and I think that people have very different communication styles, so you'll definitely run into teachers along the way whose communication styles don't match yours, which is probably putting it mildly. So yeah, no, and not to be discouraged by that one teacher, that one class. Yeah, thank you so much. Jim, did you want to chime in on that?
Over the years, like I had mentioned before, when I first came into engineering, there was a lot of people that were specialists. And I think now it seems like it's better to be a jack of all trades. So you can move to different projects. You have some background. Also, when you get into project management, if you have a little knowledge of a lot of things, you can kind of feel out what is not feeling right and what you should be worried about. Also, don't be afraid to ask questions, because people who don't ask questions worry me, because they probably are they're gonna get in trouble if they don't, because all of us should be asking questions. You don't know everything. The other thing is, be friendly, because networking is how you get things done quickly. If you do it the kind of by the book and all the steps and the paperwork, it's just a lot longer and I saw that a lot really during COVID, because I was very fortunate that I had many years with the company and I could just pick up the phone and get stuff done. Felt pretty bad for the folks that were coming in new, that didn't have the networking and knew how to get stuff done quickly. Another thing is, I would recommend folks volunteer for new stuff. You know, a new project is there, jump in there right at the beginning because you're on a level field with everybody and you're going to move up. You're going to prove yourself to the senior folks. Also, if there's a new site that's being established, you know, if you're new, go there. You're going to move up the pyramid if you're there at the beginning. I also tell folks to work proposals because if you do win that project, if you work the proposal, you work those nights till 11 p.m. You've proven yourself to the senior folks that you know you're a hard worker. You're not going to drop the ball. They can depend on you. That when they get that award and they're under contract and they're establishing the team, they're going to want to get you because you're already a leg up from everybody else, and you're going to move up and become an important part of the team.
Wonderful. Awesome. Thank you, Jim. Roey?
Yeah, so my biggest advice I'd say is two things. Don't and these are going to sound corny, but yeah, don't be scared, and always strive to learn more. And I think that's especially applicable for engineering disciplines. As far as not being scared, it's the same thing that I think Hannah had mentioned, which is that yeah, like the professors are going to try to scare you. They're going to be like, "This is a weeder class, you know, get out if you can't handle it." It's fine. It's always going to be fine. The engineering curriculums are difficult, but they're not unreasonable, and they do ease you into it. If you were ever at a point where you felt like wow, maybe I'm not, you know, maybe I can't do this, maybe I'm not gonna, you would have felt that way long before. If you get 1, 2 classes, if you get the weeder classes out of the way, it really is smooth sailing to an extent, and that you just keep working hard and you're going to keep seeing those results. As far as always striving to learn more, you know, the field is constantly expanding. That's, I'd say, a big aspect of the nature of engineering, at least from my field. If someone's, I guess, a really inherently scared person or hates learning, maybe engineer's not good. Maybe they should actually pursue it more so that they can overcome those fears and you know and develop themselves. And as far as embedded specifically, I think just one thing would be do projects and don't start with Arduino. I know it's a kind of curveball, but I have my own gripes with that. Anyone who wants to look into it, on Google, you can find plenty of reasons why Arduino is a bad starting point. But working on projects is really important. I've been on one hiring team, so I don't have much experience with this, but I've seen some entry level applications, and the majority don't have personal projects. The ones that do tend to stand out better. I wouldn't be scared of, you know, if you think that a project idea that you have isn't robust enough or isn't you know interesting or flashy. It doesn't matter. It's any dedication to learn independently, anything that you're doing on your own time is something that's going to be respected by others. And it's something that is a lot more rare than I think people think and give credit for.
That's awesome. So that was a personal project was what you were mentioning.
Yeah. Anything
Awesome.
separate, just pursuing a personal project that's
Mhm.
relevant to the field that you want to get into.
Gotcha. Yeah, I think that's great advice. Awesome. Thank you so much, Roey. Corey, sorry to put you last, but if you want to wrap us up.
That's fine. Like corny one, fail forward. Yeah, I can't, like, for the people that work below me also, there's nothing worse for me than just freezing and not doing anything. Just do something. And it's not like everything that you're thinking on the inside that it's going to be bad and this and that and this, like, we're not thinking that, we're expecting it. It's illogical to expect a new person to just magically do something really good, but what we do expect is for you to actually do something, right? So like that is like fail forward. And I also see this, and I see this with really senior engineers also, is lack of planning before the attack. And what I mean by that is, you know, you have some project and you're really excited to get it going, and you just like jump into whatever you're doing. For us, it's into the drafting and production of it. So into like a Revit, SolidWorks, Navisworks, whatever you want to call it, AutoCAD, and just like going. And it's typically not going to be right the first time, and you just wasted a lot of time because it's a lot easier to make notes and little bubbles on a board like what Hannah has right behind her, and like develop something and then go through it. So you can do it once, you can do it right, and you can do it good. And typically, we're all billable usually, so there's constraints on your project. So if you just jump in and start doing stuff and you think that you just saved your PM a bunch of time, you probably didn't. So I'd rather pull back a little bit, get some plan before you attack, and then if you fell forward after that too, fine. It was expected anyways.
Wonderful. Thank you all so much for all of your time and your thoughtful responses. I wish that we had time for questions, but I just want to respect everybody's time. So we'll go ahead and wrap up. If any of you are interested in being a resource to students, if you'd like to put your email into the chat, you're welcome to do that. And then if any of you are interested in hosting internships, or you have internship processes through the place that you work, please let me know, because I am in touch with our internship program here, and I would love to make those connections for our students. Any other questions or last comments?
I was just gonna say one other little piece of advice,
Yeah.
particularly in school, and Jim kind of touched on this of just the networking, but consider your peers, people you can network with too, of just getting study buddies and things like that.
Yeah.
And even early career, when we were all kind of starting to, try to find jobs and things like that, it was even super helpful for just we're kind of said this before, everybody's kind of confused, but it's very helpful to have people that are at your level that you're kind of figuring it out with, and they're, you kind of have different ways you're doing things, and just consider that networking as well.
Wonderful. Awesome. Thank you all again so much. And I appreciate your time. Have a wonderful, wonderful evening. And we'll talk to you later.
All right, bye.
Bye.
Dude.